Let's take a look at a quadratics application problem dealing with profit maximization together. In this example, it looks like we have a company, Dalco Manufacturing, which is estimating that its weekly profit, which is going to be measured in P or represented by P, is going to be in hundreds of dollars. This is going to be approximated by the formula where P, which is going to be the weekly profit in thousands, is going to be equal to negative 3x squared plus 6x plus 10, where x is going to be the number of units that they're produced in each week measured in thousands. Alright, so to start off, what I'm just going to do is rewrite our equation. So our profit is going to be equal to negative 3x squared plus 6x and then plus 10. Now, if you want to figure out our profit when x is equal to 0, we can find p of 0. If we plug in 0 into this equation or this function here, this is going to be negative 3 multiplied by 0 squared plus this 6 times 0 and then plus 10. So everything's going to basically cancel out to 0 here, and so we're just going to be left with 10. So if we know that p of 0 is equal to 10, we essentially know that the ordered pair of 0, 10 is going to be one of the points on this graph. Now try to think about what this point means here. X is 0, so that means that there are 0 units being produced, and 10 is representing the profit that they're making in hundreds of dollars, so 10 times 100. So even if we're not producing any units here, Dalco Manufacturing is still going to be making $1,000 in this week. Now I'm just going to visually make a sketch so you can see what's going on here. So just making a rough sketch, let's see if we can see what's going on. So we're talking about money and budgets here, so I'm not really going to need all the quadrants. I'm just going to go ahead and go into quadrant 1 and see what's going on here. So X is a number of units, and then P is going to be their weekly profit here. And we know that 0, 10 means that we're going to be producing 10 units. And we know 0, 10 here is going to be representing that y-intercept, so maybe something like this. Now, we don't know the exact information about this graph just yet, but because our leading coefficient is negative here, we do know that our graph is going to make some sort of pattern that looks like this, where it's going to come up, reach a maximum point, and then it's going to come back down, right? So we knew this just because we had a negative a value. So again, we had a quadratic equation here, and we just made a rough sketch so we can see what is going on. Now, a key word in the problem that we want to recognize is this word maximum, and that's going to make sense because if you take a look at the graph here, this is going to be where the maximum is going to occur, right? This is going to be the vertex, but it's also going to be the maximum of this parabola as well. Now, when the question asks us how many units that we're going to have to produce in order to make that maximum profit, that's going to be telling us or asking us to find out this x value here, which we're going to find along the x-axis right over here. I'm going to go ahead and call this value h here. And so this right here is basically what we call our axis of symmetry, or this imaginary vertical line. That's going to tell us the amount of units that we have to sell to maximize the profit. And the amount of profit that we would get when we maximize is going to be this y value here. I'm going to call this one k. And so if we go ahead and find out the ordered pair for this vertex, we're going to find out it's going to be h, k. This h is going to represent the number of units we need to sell measured in thousands, and then k is going to represent the amount of profit that the company makes in a week measured in hundreds. Alright, so what's our formula for the AOS, or for the axis of symmetry? Well, that's going to be x is equal to the opposite of b divided by 2a. Now in this particular case, what is a and b? What are a and b? So a is going to be negative 3 and b is going to be positive 6. So I'm going to go ahead and write that on the side here, that a equals that negative 3 and b equals that positive 6. So if we go ahead and substitute in, we're going to get x is equal to the opposite of b, or negative 6, all over 2a, which is going to be 2 times this negative 3. 2 times negative 3 is going to be negative 6. So we're going to get negative 6 over negative 6. So we're going to get that our axis of symmetry is equal to 1. Now specifically in this case, I'm going to call that one h. So I'm just going to go ahead and replace this and say that h is equal to 1. So when we know that x value is equal to 1, that's going to tell us where the maximum profit is going to take place. So that 1 is really just 1,000 units. They're going to go ahead and maximize their profit. It seems like if they sell less than 1,000 units, you can see that these have all x values that are less than 1. Then their profits are going to be lower depending on where you are along the curve. As you get closer and closer to selling 1,000 units, the profit gets maximized. And as you get more and more, or get further away from 1,000, as you sell even more units, at a certain point you can see that the profit is also dropping. So as you approach that x value of 1, you then maximize your profit when x equals 1, and then when you go past 1,000 units, or when x equals 1, the profit starts diminishing as well. Alright, in part B, what they're asking us to do is go ahead and find that maximum weekly profit, so we're going to use that information from part A to do so. So let's go ahead and write our function down again. It was p of x is equal to negative 3x squared plus 6x, and it was plus 10. And so what we want to find out here is that maximum weekly profit. So we know that it's going to occur when x is equal to 1. So we're going to say P of 1, or replace x with 1, or 1,000 units. That's going to be negative 3 multiplied by 1 squared plus 6 multiplied by 1 plus 10. And so really we just have some order of operations to do here. So evaluating this expression when x is 1, 1 squared is 1, 1 times a negative 3, that's going to equal negative 3. Plus, we have this 6 times 1, that's just going to equal 6. And then finally, we're going to add the 10 here. So when x is 1, or when 1,000 units are produced, negative 3 plus 6 is going to be 3, plus the 10 is going to be 13. So we're going to see here that we have 1 comma 13, and that's going to be a significant point here. So if you link this back to what we talked about earlier, the 1 really represents if they produced 1,000 of those units. The 13 we just found out is going to be 13 times 100, because again, it was measured, the profit was measured in hundreds. So this is basically our h comma k. So this is going to be telling us how many units they would have to produce to maximize their profit. This is 1,000 units, and this 13 is going to be 13 times 100, or $1,300 would be their maximum profit they could make in that week if they sold that 1,000 units. So if we go back and look at this graph we have together, I think it's going to be important to kind of just summarize and put this all together here, that for the AOS here, we're saying x is equal to 1. I kind of use the h and k just because of those variables we use in vertex form. And then here we can just go ahead and plug in those values and say this is 1 comma 13. That lets us know our maximum and when it gets us to our maximum. So let's go ahead and summarize this as well. And so when the company produces 1,000 of these units, they're going to maximize their profit at 13, which is the Y value, or multiplying this 13 by 100, because these are measured in hundreds, this would be $1,300 of profit per week. And so if we were to sell 1,000 of those units, the maximum weekly profit is going to be $1,300. All right, so there you have an example practice problem dealing with profit maximization when dealing with quadratic equations. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.